Let's solve these two questions about finding a particular term in an arithmetic sequence. All you need to know to answer questions like this is that an arithmetic sequence is defined by a starting term, like in this first question, we start with 2, and a common difference. Like in this first sequence, the common difference is 6. The sequence starts at 2, and then it goes up 6 to 8. And that difference of 6 is consistent. It goes up 6 again to 14, and then up 6 again to 20, and so on. So this first question is, given this arithmetic sequence, what's the value of the 13th term of the sequence? Perhaps the simplest way to do this is to take the first term, which we might write as A1, the first term of the arithmetic sequence. This was given to us as 2. So we could take that and use it to find the 13th term. Here's how. A13, the 13th term of the sequence, is going to be 2, the starting term, but then we need to move up or move forward 12 terms because we need to go from the first to the 13th. So we'll write plus 12, but for each of these 12 terms we're moving forward, we need to increase by the common difference of 6. So it's just plus 12 times 6. Again, that's because we're going up 12 terms from the first term to the 13th term, but for each step, we need to increase by 6. So it's 2, the starting term, plus 12 times 6. And this is equal to 2 plus 12 times 6 is 72. We see this is equal to 74. That's the 13th term of the sequence. And there are multiple ways to do this. We also could have taken the fourth term, which was given to us as 20, and then in that case, we'd have to go up 9 steps from the fourth term to the 13th term. Same idea though. We would increase 9 times 6 because we're going up 9 terms, and for each step we go up, we need to increase by the common difference of 6. So we just take that fourth term 20, add 9 times 6. Again, the answer is 74. In the second question, we're told that the fourth term of an arithmetic sequence is 13, and the ninth term is 33. So the question is, what's the value of the 19th term? Let's just write the information that we have, that the fourth term, that we might call A4, is 13, and the ninth term, we'll call A9, is equal to 33. Using similar reason as for the previous question, we can write that 13, the fourth term, plus the number of steps you have to increase to get to the ninth term, which is 5, right? From 4 to 9 is an increase of 5 terms. But each time we go forward a term, we need to increase by the common difference. We don't know what the common difference is. Let's just call it D, and we'll be able to figure it out. Now, what is this equal to? Well, we're starting at the fourth term, which is 13, and then we're going up 5 terms. That's going to get us to the ninth term, which we know is 33. And then we can just solve this equation for D, and we'll be able to figure out the answer from there. By solving for D, we're going to have to subtract 13 from both sides, and that's going to leave 5D on the left. 33 minus 13 is 20. Divide everything by 5, and we find that D is equal to 4. So this arithmetic sequence is going to increase by 4 each term we move forward, and we can use that to find the 19th term. So what is the 19th term, A19, of this arithmetic sequence? Well, we could start with, say, the ninth term, which we know is 33, and then how many terms forward do we need to go to get to the 19th term? Well, if we're starting at the 9th, we need to go forward 10 to get to the 19th. Each time we go forward a term, though, we know we need to increase by this common difference, which we figured out was 4. And so we see that the 19th term has to be 33 plus 10 times 4. 10 times 4 is 40, and so this is just 73. That is the 19th term. One more note before we finish. Using the same sort of reasoning, we can also go backwards in an arithmetic sequence. For example, we could figure out the first term by starting at the 19th term, say, and that's 73, and then we're going to have to go back how many terms to get from the 19th to the first? Well, we'll have to go back 18 terms because that's the difference between 19 and 1. All right, so we're going back, as in subtraction, we're going back 18 terms, Each time we move back a term is going to cause a difference of 4. And so the first term is going to be 73 minus 18 times 4. 18 times 4 is 72, and 73 minus 72 is 1. So the first term of the sequence is 1. Notice we'd also get that same thing if we had done this starting with the fourth term. We could start with the fourth term, which is 13, and try to back it up to the first term. So we would say, how are we going to calculate the first term? Well, let's take the fourth term, which is 13, and then we're going to have to back up 3 terms, and each time we go back a term is going to cause a difference of 4. So that's 13 minus 12. Again, it's 1. So with this simple idea of common differences, as long as you can figure out what that common difference is, you can move forward and backward along an arithmetic sequence with ease. Hope this was helpful. Let me know in the comments if you have any questions.
Parted hearts and heavy minds weighed down by the catalyst, sinking to the stomachs that plummeted at the accident. Shot off all my habits to addicts ripped by a catapult, pulled apart the patterns in man that stood as a manifold. Man of many pains with a number that he had to call, calculate the damage of himself and what's collateral, being told he's not enough until he swallowed.